Okay, this is problem 17. The directions are to apply Rolle's theorem. Well, first determine if Rolle's theorem can be applied. Then if it can be applied, then find the guaranteed C, the value of x, where Rolle's theorem guarantees that value. Alright, so first of all, you got to see if this function is continuous on this interval. Well, this function is not continuous at x equals -2, and x equals -2 is not part of this interval, so it is continuous in that interval. Now you check to see if f of -1, what f of -1 is. So you plug in -1, so it'll be 1 plus 2 minus 3 over 1, which is 0. And you plug in 3, and that'll be 3 squared minus 6 minus 3 over 5, which is also 0. Right? Oh, that was also the requirement of Rolle's theorem, that the values are the same. Alright, so now we need to find f prime of c where it's equal to 0. So we need the derivative. So let's take the derivative, so it's quotient rule, x plus 2 times 2x minus 2. Right, it's a derivative of the numerator. Okay, minus the derivative denominator, which is 1, times the numerator. All over the denominator squared. Alright, recap. Bring up the denominator, take the derivative of the numerator. Right, the derivative of the numerator is 2x minus 2, minus the derivative of the denominator, which is 1, times the numerator, x squared minus 2x minus 3. Alright, let's clean that up. Go ahead and multiply that out. So that would be 2x squared plus 4x minus 2x makes plus 2x minus 4. I'm going to distribute that negative. So it's negative x squared plus 2x plus 3 all over x plus 2 quantity squared. And so that would be x squared plus 4x minus 1 over x plus 2 squared. Alright, and we want this equal to 0. We want this derivative equal to 0. So we set equal to 0. Remember, for a fraction equals 0, only the numerator need equal 0. So we're basically solving this equation. From experience, you can see that this function, or this quadratic, cannot be factored. So we just use quadratic formula. So that'll be -4 plus or minus the square root of 4 squared minus 4 times 1 times -1 all over 2. So that's -4 plus or minus square root of 20 over 2. And what is that? -4 plus or minus 2 root 5 over 2. So that's -2 plus or minus root 5. Ooh, looks like there was a typo in the answer key. Is that why you guys requested this? Because you don't know how I got the 1? I think it was a 1 on the answer key, wasn't it? Let's go take a look. I think it's still recording. And where is this? Use the mouse. No, it says -2. Okay. Alright. Alright, so how do you choose between plus or minus? Well, -2 minus square root of 5 is definitely outside of this, right? If you subtract square root of 5 or subtract anything from -2, it's even further left. So then that must mean the -2 plus square root of 5 is actually in that interval. -2 plus the square root of 5. Alright, that's it. That's number 17. Here's problem 23. Again, you're applying Rolle's theorem. If Rolle's theorem applies, find the value of c. So, first of all, on the interval 0 to pi, tangent of x is undefined. Tan x is undefined at x equals pi halves. So Rolle's theorem does not apply because it's not continuous. So that's it. Okay. Okay, now. Okay, 47. I'm looking for the instructions for 47. This one's doing mean value theorem. All right, mean value theorem. Right. Okay. So all I basically did was reread the answer to you. So let's go back and look at this again. Right. Tangent of x is equal to sine x over cosine x. Cosine x equals 0 when x is pi over 2. Okay. So tangent is undefined at x equals pi over 2. So it's not continuous. So I am confused by this question. So does that mean that we don't know that tangent is undefined at x equals pi halves? That is another issue. Okay. Or you didn't know to check to see if it was undefined at all. Alright? So remember, for Rolle's theorem to apply, it has to be continuous. If a function is undefined, it is not continuous. Right? This is undefined at x equals pi halves, so it's not continuous. So function tangent x is not continuous at x equals pi halves. Okay. 47. Same instructions. Oh no, this one's mean value theorem. So sine x is continuous for all real numbers, so no problem. Sine x is differentiable for all real numbers, so no problem. Right? So it meets continuity, it meets differentiability. So now you just plug in the values. So what is f of 0? F of 0 is sine of 0, which is 0. And what is f of pi, which is sine of pi, which is also 0. So actually Rolle's theorem can apply here. Right? So that means we find f prime of c such that sine of pi minus the sine of 0 over pi minus 0, right, which is equal to 0. All right. So when is sine x, when is the derivative of this function equal to 0? So take the derivative. So f prime of x equals cosine x. When is cosine x equal to 0? It's equal to 0 when it's pi over 2. All right. There are other places where it's equal to 0. However, it's the only value on this interval where it's equal to 0. All right, this is problem 64. You notice that I tried this once before, so I'm trying it again. All right, so you're given some information about your function. You're given that it's continuous and differentiable, meaning this is not it. There's more to this function. They only gave you a piece of it. Okay, so if you're thinking that they gave you the entire function and that's why you're confused, well, that's not it. They said it's continuous and they only gave you parts of the function, not the whole function, right? They said that the figure shows 2 parts of the graph of a continuous differentiable function, right? So they're left out this big gap. So they're not implying that this function has a gap in it. They're implying that this function doesn't have a gap. They only just drawn the 2 parts for you. That's all. All right. So part A, explain why f must have at least one zero. Okay. You're told that it's continuous. Continuity is enough for the intermediate value theorem. So by the intermediate value theorem, because it's continuous, and there's a positive y value and a negative y value, there must be at least one zero. All right. So that's A. By the intermediate value theorem, there must be at least one zero. B. Explain why f prime must have at least one zero in the interval -10 to 4. Okay, so look what you got here. So there's a y value that's equal to 2. Okay, there's a y value that's equal to 2. And for it to come down here, it has to hit 2 again. Okay, so by the Rolle's theorem, right, because you have f of some value a is equal to 2 and f of some value b is equal to 2, Rolle's theorem applies because it's continuous and differentiable. Remember, it was continuous and differentiable. So that means Rolle's theorem applies. And because Rolle's theorem is applied, there must be one value such that f prime of c, where c is in between, where a is less than c is less than b. Okay? And that's got to equal 0. So that's by Rolle's theorem or the mean value theorem. Either one's fine. Okay? Remember, Rolle's theorem is the special case of mean value theorem. So you could just say by mean value theorem, there must be a point C such that derivative equals 0. Part C, make a possible sketch of the function with 1, 0 of f prime on the interval. 1, 0 of f prime on the interval. Well, so you can just go like this. That's it. So the 1, 0 is here. And there's no other zeros here. Okay? But let's pretend that it's not so crappy looking there. Alright. D, make a possible sketch of it with 2 zeros on the interval. So 2 zeros on the interval. Alright. So let's do that. So then it will look kind of like. So what I'm trying to, so obviously a 0 here, and then I'm trying to make it level off here without becoming a max or a min. So that will be the other one, where the other 0 is not a max or a min, right? Because when it says with 2 zeros, they mean exactly 2 zeros, not at least 2 zeros. So that's 1, 0, and then it levels off, but it keeps going down. Kind of like the graph of y equals x cubed. It levels off, but it keeps going up. I want to do the same thing here, except going downwards. All right. So that would connect this left side over here and the right side over here. All right. That's D. E, were the conditions of continuity of f and f prime necessary to do parts A through D? That's a good question. I don't remember. It says no. Really? Alright, were the conditions of continuity f and f prime necessary to do parts A through D? A through D. Oh. Hold on. Alright, so yeah, it caught me too. So the key here is in E, they're talking about the interval -10 to 4. Right? They're talking about the closed interval. But remember, those theorems say it has to be differentiable on the open interval. So that's a trick question. So yeah, they got me too. So for part E, were the conditions of continuity for f and f prime necessary to do parts A through D? No, right? Because you don't need differentiability on the closed interval. You only need differentiability on the open interval. So that was kind of lame. All right. That's it. I think I'm done.